So what we're going to do this part 4 is look at some of the sort of the modifications, the tweaks, the issues. We're going to look at things like anchoring to get absolute rankings, best, whether best can be equal to worst, and so on. So this is sort of technical issues that you might want to be concerned about or worried about when you're looking at the analysis as to whether your results are whether it's appropriate for you to interpret the results in the way that we have been. So first question is, are the best and the worst choices the same? So this is essentially asking the question, was the rating scale that I was using when I picked the best out of the 4 the same as the rating scale that I was using when I was picking the worst? And you may think, well, how can that be changed? Well, but actually it seems if that sometimes does happen, that the way people are rating items is changed by the framing as to, are you trying to pick the best or the worst, as if they don't have a single scale. Not always, but it can happen. So the question is, well, you'd like to know that and you'd like to test for it. How do you test it? Well, we can only do this in the statistical approaches. So what we're going to do is we're going to estimate separate models on just the best data, i.e. just the choices from the best part, and then we're going to repeat another model which is just using the worst choices, and then we're going to compare that with our stacked model, because the first two give complete freedom as to what the parameters are in the best and the worst and could reveal interesting things, but in that stacked data they're restricted to be the same. So we can do a formal test of whether or not I can impose that the way I'm picking my best is equivalent to the way that I'm picking my worst. So let's look at this. So we're going to use, this is the ACR data, this is on the 8 different policy regimes for improving farm livelihoods. For this one I'm going to use the Bangladesh data, and here what we've got is a set of results that's coming just from the best choices. So we do exactly the same thing, it looks exactly the same, but I know because the sample size that what I've got here is basically the best data. What we can see, well, D2, this is dummy coded, so D8 is out of the way. D2 and D4 significantly better than item 8. What else we've got? Item 6 worse than. So we're getting some discrimination on the bests. So now we can just come and re-estimate the model, but this time only with the worst choices. So because we've done the reverse coding on the D's on here, the coefficients stay the same, so we're still seeing the same numerical values. And what you can see is that before D2 seemed to be more was being rated highly, but here when we're looking at the worst, actually it doesn't seem to be. It's not different to 8, so there might be some evidence here. What do we do? Well, we need to compare that. This is the combined data sets, this is the stacked data sets. These are the results that we saw, or underpin the results we saw before when we looked at the 3 country and the relative weights. So we estimate this one, and when we combine the two, well, D2 is positive, just about significant, but you can see its effect has been moderated by the fact that it doesn't actually seem to be significant in the worst, but it is in the best. D4 seems to be pretty stable. D6 seems to be pretty stable across all of them. But once we've done that, we can actually do a formal test. So what we're going to do is we're going to see whether or not we can restrict the coefficients in the best and the worst to be the same, and therefore to have a single model here. And this is what's known as a log likelihood ratio test. And it just depends, it asks the question, well, how much improvement in fit do I get by giving it the freedom to have different parameters for the best and worst as compared to the restricted. And what this is doing here in terms of this log likelihood ratio test, actually this comes out and says, well, statistically you could actually impose that actually the best and the worst sequences are the same. So although numerically it looks like there's a difference here, actually it's because the sample size isn't that large, and when we're only using the best and the worst choices, we're getting. So actually the power of our tests here are not that high, so that when we actually estimate this, actually this may just be the deviations that we're seeing are probably are consistent with just random sort of sampling error but not something systematic. So we can actually go back and say that, well, yes, for this data we're fine. We can actually quite happy to work with the situation where the best and worst are the same. Now we'll do the same thing for the Nepalese data. And because I'm doing this twice, you might guess what's going to happen. That's the best, there's the worst. What you can see, we're getting some similar sort of effects turning up. Here we're coming in with the merged ones, or the combined ones, the stacked data, and then we do a test. And actually here, it's not dramatically different, but it is actually saying, well, statistically, actually, it doesn't look as if actually we've got the same results. And you can sort of see where this might be happening. This is probably happening here in D4 is what's probably causing the problem, because here that was insignificant, but here in the best, whereas here it's definitely negative and significant. And what it's just confirming is that, well, actually no, you probably shouldn't be combining these two together into best and worst. There's sort of a next step before we confirm that conclusion, because there's also some work which suggests that actually that people may have consistent ratings, but just that they are more uncertain, more random in their choices. There's more noise in the error process on the worsts. So to do that, you can estimate one of these heteroscedastic regressions that just says we're going to impose that they have the same parameters, preference parameters, the scaling, the rating parameters are the same for best and worst, but we're just going to allow the variance to be different between the two. We'll see are they when they're confronted with this thing of trying to pick a worst, are they more noisy in their choices? Well, actually, it turns out they're not. And so we still fail the test to be able to restrict them together. So then you have a question, what do? Do you just report the best, or do you report the best and the worst, or do you just say, I'm going to report the average of the two? With this sample, it's not the worst rejection I've ever seen in terms of the best and worst. You might say, well, we'll just report the averages across them. But it's something you may want to check in your data. And as I said, it can only be done in the regression models. So now this idea of absolute scale, this is like an example of the choice set. The respondent is confronted with this question. You have to choose the most and the least effective. Again, this is off our example. ACR project, and you're sort of forced where you have to pick one is most and one is least, and I could do that, but I may actually be sitting there thinking, well, actually, although I can rate best and worst, I think all four of those are just not particularly sensible policies. As in, if I had to choose one to implement, I wouldn't choose any. I wouldn't even choose the one I've said is best. So, or most effective. So it's perfectly possible for me to say, okay, I think out of this set that you forced me to choose between, this is the most effective, but by the way, I would never recommend that we do that because it's a really bad thing to do. So these best worst scaling questions sort of sit in sort of the frame of forced choices, as in you have to make make a choice between most and least, and you're not allowed to, in the standard approach, to sort of turn around and say, yes, but none of these are any good, really. Well, people have thought about that, and they've introduced this idea of anchors, and the anchor tries to put the results onto an absolute scale. So this is an example, and I'm going to use this one rather than, because we didn't actually use this anchoring in our project, so I'm going to use a different one. So this is an example of where they have given the least of most important. This again is about water, and for a product, well, actually this is for a product, but it involves how it's being produced in terms of washed and so on. And they're being asked to do the least and the most, but then they are also being asked at the end, considering all these 4 features, are none of the 4 actually important to you in absolute terms? Are some important, some not, or all 4 important? And so this introduces this idea of an anchor. This idea of this absolute level of importance is going to give us some sense of an absolute measure of value. How does that do that? Well, if they select none of these 4 is important, then we know that all 4 items lie below, if you like, this anchor, this point of indifference, this point of saying, no, I just don't think this is worth it. So we now know that if they pick the first of those, this one here, all 4 of them lie beneath that sort of absolute scale. If they select all 4 important, then they all lie above that anchor point. And if they select some are important, some are not, then what we know is that the best one must lie above my absolute threshold, and the worst one must lie below my absolute threshold, but we don't know what happens with the 2 in between. Once you've got that information, you can then use that basically at the point of estimation to actually make sure that when you're estimating it, that the scales, the scores that are given to the items, all those that lie above this absolute have all got positive values, and all those that lie below have got negative values. So we're still using the information about what's best and worst. That's still telling us something about the rankings, but now we're getting this extra information about where is this absolute level, this anchor. So that anchor, value of 0, those above all. Is it worth doing? It can be. It just introduces an extra level of complexity into your data analysis, into your data collection. You have to ask some form of that anchoring question of people, so it just adds an extra little layer of complexity. But it can be fairly useful to have that if you want to be able to have this idea of not just a forced choice which gives you the relative rankings, but an absolute choice. Which of these products would you actually buy? Which of these policy interventions would you actually want to see implemented, or do you think that actually it's not even worth the bother? So there's details are in the Sawtooth report, the technical paper on the MaxDiff system, where it goes into how you actually implement it. So this has been done, again, this is an unpublished study by my colleague Dan Rigby at Manchester. This was again about foodborne illness. This is about chicken production, and here they had a ranking of these different ways that they could intervene in order to reduce the disease burden of chicken. So remove the neck skins, put a label on saying don't wash it, whatever. So lots of different ways, and they had a large set of these. And then what they did, their form of the anchor they put in was, at the end of the choice questions, they put in this threshold question, which is, well, which of these are acceptable or unacceptable? So again, they're not asking them to rate them, just which do you think these are acceptable? So you might imagine, actually, given the sensitivities in Europe at the moment, that actually the chlorine wash, which is something that the Americans do, might actually just fit into the unacceptable to me. Don't like that. I might have scored it in terms of its best worst, but I'm now just telling you it doesn't meet my threshold. And there may be some irradiation might be the same thing. I may also say that's just not acceptable to me. I don't want that. So I'm not just telling you its relative position, but I'm telling you where it is relative to the anchor. And then when they did the estimation of that, what you can see is, well, there we go. Here's the anchor at 0 in the middle of the set, and then here are the items, and these have been nicely ordered for us. So the one which is most highly scored and is up above the acceptance, the anchor level, farmers being paid. and then obviously you see it declines. Receiving food additives is the lowest of the acceptable ones, and then here we flip into things which are still being rated and ranked and put on a scale, but now we are being told actually they would not be acceptable to the consumer. And you can see various interventions, all frozen, irradiation, chlorine wash. Things that you might have guessed might not have been acceptable to consumers. They are falling below the anchor. We wouldn't have had that information if we'd just estimated the model without having the anchor in place. So putting anchors in, I think, is a interesting issue that can be considered. Okay, part 5. This is very short, as a couple of slides, so we'll just keep rolling. So this is just about resources and software and how one might, if one wanted to implement, how one might go about it. There are a whole sequence of texts, textbooks which deal with these issues, and so these aren't so much about applications. These are just setting out the process. So the one which I think is particularly useful and valuable is the first one, as in Louviere, who initiated this whole best worst scaling methodology approach, has this textbook. It's very good in the sense that it actually works through and shows you what they've done and how you implement, and I sort of followed parts of that book in order to, when I prepared the presentations. There's a nice book which the stated preference methods using R. The R is a free software package, and they work through how to do designs in R, but then also how to set up and do estimation as well. So that's, I think, a useful one. The Sawtooth is a company that runs commercial software. They've done a lot of the development of the ideas and the theory behind this, but they've then embedded that inside their software. It's expensive, but even if you're not using their software, reading their texts, their technical papers is really insightful, because they have been some of the leaders in developing this. This is the recommendation of putting this little paper on. This is one that I've been involved with. The reason I put this on is that this one has it's a psychology paper, so it's an applied one, but what it also has is an appendix, which is a how-to step-by-step guide as to how you could implement a best worst scaling experiment. It talks about how to get things into R and how to do the analysis and so on. So I'm not so much recommending that one for the application that it has, but for the recommendation that the technical appendix, which sort of gives advice as to how to do it. Then, what software do you use? Well, you can go across a whole range of this. In principle, you could do one of these studies with almost no requirements. You could do it on paper. You could get the design just from looking up one of the vivid designs out of the catalogue. That would let you sort of generate those. You could, when you get the data back in, you could analyze the data just using counts, as we've shown in Excel. So at some level, this can be implemented really quite at a low cost in terms of infrastructure. Next step up is that you could go any sort of online software that can present a table of items. So Qualtrics or SurveyMonkey, whatever, anything where you could just embed your designs into it and just ask people to choose a best and a worst out of this set and rotate them through multiple sets. That would let you get away from the paper-based approach. It is not complicated to set these up in that, and you could still do the analysis in Excel. If you want to move to doing the statistical, you just need any statistical software that can estimate basically a conditional logit model. So R and the previous examples that was setting out how you would do that in R which is the free software package, or something like Stata or SPSS. Pretty standard. There's nothing but hugely fancy in terms of the statistical software that you need to be able to implement these types of models. And then I think that the one which is most expensive and most complete is the Sawtooth software, the commercial software. It can design choice sets. You feed it an object list, 30 items. You can either then feed it a BIBIC design, or you can ask it to do its own design. It generates the choice sets and presents them embedded inside the survey, along with the sort of normal standard demographic, whatever questions. It can present it in that online mode, and then it also has embedded an advanced analysis capability, so it can estimate the simple, having got the data, collect the data in, you can just do the analysis either by individuals or average in the way I've shown. It also got a whole range of these more advanced statistical techniques which I haven't talked about, but because basically they are at the forefront of developing these, those are all sort of embedded into that software. But it is, as I say, it's commercial and it's quite expensive. So depending on where you are, what your budget and your investment and commitment to this type of study is, you can go across a range of different levels of cost. And then just finally, this is just all the references we've talked about. Just brought together into a single list. So I hope that's been useful. As I said at the start, the purpose of this isn't to give you an exhaustive course in best worst scaling. We may have taken an hour or so in terms of talking about these things, but hopefully it has given you a sense as to the principles behind it, how it gets implemented, some of the technical issues behind how to undertake the study, and so if you do think that you might want to implement one of these, hopefully now you've got a good idea as to what's involved. So thank you all very much.